Alright, gang, let's look at our notes for today. Let's look at quadratic functions. So the parent function for a quadratic function, y equals x squared. Okay, again, we could say y or f of x. Those mean the same thing. Is x squared. It creates a U-shaped curve that's called a parabola. The blank, blank, blank is a vertical line that divides the parabola into two congruent parts. We call that the axis of symmetry. Okay, you could hear axis of symmetry. You could also hear line of symmetry. It means the exact same thing. The turning point is called the vertex. So some key vocabulary that is associated with our quadratics. Alright, so the axis of symmetry divides a parabola into two congruent parts, or two congruent halves. And then the vertex is the turning point, which is either the highest or it's the lowest point on the graph. Either the highest or the lowest point on the graph. Now we have two different forms when we're dealing with quadratics. We're going to talk about our standard form first. Our standard form is ax squared plus bx plus c. That's what you're used to seeing. Okay, that's what you're used to seeing. And as far as our now, again, that axis of symmetry is a thing that divides the parabola into two congruent parts. We say that the axis of symmetry, the formula is x equals negative b over 2a. Negative b being that right there over 2 times a. A is the leading coefficient of the x squared value. Alright, so we're going to then we would plug that back in to find the vertex. Why? Okay, because this is going to be the x value of your vertex. This is going to be the x value of your vertex. So let's look at an example. So our example is x squared minus 4x plus 1. X squared minus 4x plus 1. So the first thing I'm going to do is I'm going to plug that into this to find my axis of symmetry. And I'll show you what you get when you do that. So x equals negative b. Again, this is a. This is b. This is c. A is the number in front. So a would be 1. B is going to be a negative 4, and C is going to be a positive 1. So we have x equals negative B, so negative 4 over 2 times 1, 2 times A. So negative 4 is going to give me a positive 4 over 2, which is going to be equal to 2 over 1. So we know that the x value of our vertex of symmetry and the the axis of symmetry, excuse me, and our vertex is at x equals 2. Right? So we know that our axis of symmetry is going to be along this line right here. Now, we're going to take this value and plug it back in to find the y-coordinate of our vertex. So I'm going to say our first point, let's put it about right in here, about in the middle. Okay. First point that we're going to find is when x is going to be equal to 2. So we have 2 squared minus 4 times 2 plus 1. Well, 2 squared is 4 minus 4 plus 1. So our vertex is going to be at 2, 1. Sorry, I did not do that right. Holy smokes. 2 squared is 4 minus 8 plus 1. Coach Sapp, you don't know what you're doing. Negative 3, right? So at positive 2, negative 3. There we go. That looks more like it. All right, now, if I look here, I have a positive leading coefficient. So if I have a positive leading coefficient, I know that the graph is opening upward. Let's find another point. So let's just pick 1. So if I plug in 1, I've got 1 squared, which is 1, minus 4 times 1. So 1 minus 4, negative 3, plus 1, which is a negative 2. So I have a point at 1, negative 2. Now, this point at 1, negative 2 is 1 unit away from the axis of symmetry. So I know that at at positive 3, I have a point that corresponds to that point. Because again, axis of symmetry divides the parabola into congruent parts. So if this is 1 unit away, I have another coordinate that is 1 unit on the other side. So I have a point at 3, negative 2. If I plug in 0, 0 squared is 0, minus 4 times 0, positive 1. So at 0, it's at positive 1. Now that is 2 units away. So the point at positive 4 is going to also be 1. And so on and so forth. So your parabola looks like that. Alright, let's look at the vertex form. Okay, so the vertex form for a Quadratic is y, or f of x. I'm just going to write f of x this time. So f of x equals a x minus h squared plus k. Okay, so the axis of symmetry in this case is going to be x equals h. X equals h. And h is going to be the x value of my vertex. K is going to be the y value of my vertex. So h and k are the points, the coordinates of my vertex. That's why we call it the vertex form, because you're given your vertex. Right, so I know right now I have a vertex at -1, -1, +6. -1, +6. Now, why is it -1? Because look in my formula. My formula is already a minus sign. So I plugged in a -1 to get that positive sign right there, because a negative makes a plus. So I have a vertex at a -1, +6. Okay, I can look at my a value. My leading coefficient is negative, so I know the parabola is opening downward. The parabola is opening downward. Okay, and once again, we know that the axis of symmetry is going to go through the x value of my vertex, right? So the axis of symmetry is right there. All right, if I plug in 0, I get 0, +4. So a point at 0, +4. That means I also have a point at -2, +4. Okay, if I plug in -3, I get -2. So at -3, -2, which means that I also have a point at +1, -2. So my parabola looks like that. Okay, I just realized that I didn't fill in the parent function. The parent function is going to go through the origin. The vertex is at 0, 0. Okay, looks like that's right there. Okay, if you want some points on that table, let's start at 0, 0 here. Right, we have a point at +1, 1, and also at -1, 1. Okay, so my graph is a little bit off. I have a point at 2, 4. There we go, I made up for it. And -2, 4. Okay. Looks like that right there.